Hey, welcome back. This is the second video for sections 5.1, 5.2. Now for objective 3, we're going to use a graphing calculator to solve this system. This example here that we have in front of us is the same example that we did for example 1. The first step is to write it in its augmented matrix form. So we are going to write 1 and -1, 1, 9, 8, and then 2, 3, -1, -2, 3, -2, -9, and 9. And let's head over to the calculator to have the calculator solve this form for us. To do this, actually, let me share my calculator screen first. Okay, to go into the matrix, you're going to press second, and then the matrix is right here. So second matrix, and we're going to enter our matrix in. So go to edit and choose 1. And then it asks you what your dimensions are. This is a 3 by 4 matrix. And then it gives us a space to write our coefficients in. So you just have to type it all in, make sure you do it correctly. It's 1, -1, 1, and 8. The second row is 2, 3, -1, -2. And then the third row, we got 3, -2, -9, and 9. Okay, once we have it in, we just have to make sure that it's in correctly, because if one of the answers or one of the numbers are wrong, it'll throw the whole answer off. Okay, so I double checked, it looks right. You're going to clear this, quit out of that screen, and then go to the matrix screen again. And we're going to go to math and go all the way down to B, RREF. This stands for reduced row echelon form. And what this does is it reduces our matrix, and so that we can find out what our solutions are. So we pulled out called the function RREF, and then we have to call back our original matrix. It was A, so we're going to select A. And it gives us this new matrix, and we're going to copy this down. Notice how all the ones are in a diagonal and all the other entries are zeros except for the last column. So let's head back to our guided notes and write that down. Okay, so it was using reduced row echelon form. We had this new matrix. It was 1, 0, 0, 4, 0, 1, 0, -3, 0, 0, 1, 1. Okay, so what this means is, remember this was x, y, z, and then equals a constant, that x is equal to 4. The second row tells us that y is equal to -3. The last row tells us that z is equal to 1. And this is the same solution we got by using the elimination process. Okay, for -3 and 1. Okay, let's look at another case where we may come across an inconsistent system of equations. What that means is it may not have a solution that satisfies all 3 equations. So let's consider this example. X minus 3y plus z equals 4, -x plus 2y minus 5z equals 3, 5x minus 13y plus 13z equals 8. First thing we want to do is put it in its augmented matrix. Okay, so 1, -3, 1, and then 4. We have -1, 2, -5, 3, and 5, -13, 13, and 8. We're going to use the reduced row echelon function in our calculator. Okay, so let's head back to our calculator and then put that matrix in. So we go to second matrix, go to edit, It's already in 3 by 4 from last time, so we just have to replace all these values. 1, -3, 1, 4, and -1, 2, -5, 3. The last row is 5, -13, and 13, 8. Okay, double checking that our values are correctly entered, and then quit out of that screen. Just going to copy and paste this function. So it gives us a new reduced row matrix. So let's head back to our page and copy that down. So it looks like 1, 0, 13, and 0, 0, 1, 4, 0, 0, 0, 0, 1. Okay, so what do you notice that's different from this matrix compared to the previous one? You may notice, right, the previous matrix had 1s all in this diagonal with 0s in the other spaces. This is different. That if you look at the last row, what this last row tells us is that 0 is equal to 1. Well, then 0 equals 1 is an inconsistent equation, right? It's a contradiction. 0 can never equal 1. So that means this equation, these systems, is inconsistent. Therefore, this system has no solution. Okay. Let's look at the last type. Now, you may also find an equation where there are an infinite number of solutions. We call this a dependent system. And so to find the solution of this given system, let's first rewrite this as a matrix. 3, -4, 4, 7. Oops, that should be a 7. 1, -1, -2, 2, -3, 6, and 2, 5. I'm going to head back to the calculator and put this matrix in. Okay, second matrix, go to edit. Let's replace all those values from the previous problem. We have 3, -4, 4, 7, 1, -1, -2, 2, and I think I may have put this in wrong. Okay, okay, 3, -4, 4, 7, 1, -1, -2, 2, 2, -3, 6, and 5. Okay, always double check that it's incorrectly, and it is, so quit out. And actually, I'm just going to go up and then copy reduce row echelon of matrix A, and we get this matrix. So let's go back and copy this onto our paper. So we get 1, 0, -12, 1, and then 0, 1, -10, -1, and 0, 0, 0, 0. Okay, this one looks different too. If you look at the very bottom row, you get all zeros. So what we can conclude from this bottom row is that 0 equals 0. What does that mean? It means that we have an identity, which means the solution has many infinite number of solutions. Infinite number of solutions. And so we need to find what that infinite number of solutions mean. So from the first row, we can extract that x minus 12z is equal to 1. From the second row, we can write y minus 10z equals -1. Remember, because the first column is x, the coefficients for x, and then the second column are the coefficients for y and z, and then we got the constant at the end. The last row is just z is just equal to z. Okay, so let's have or isolate the x from -12z equals 1. Well, we can add 12z to both sides and get that x is equal to, I should have written x is equal to 1 plus 12z. And from the second equation, let's isolate the y. Y is equal to -1 plus 10z. And so our solution is x can be expressed as 1 plus 12z. Y can be expressed as -1 plus 10z. And then z is just z. What this means is the solutions will depend on what you choose for z. And z, what is z? Z is any real number. And x and y depends on z. So if z is 0, right? X would be 1 and y would be -1. And you could choose z to be 1 and x and y would be different. If you choose z to be 2, x and y would be different depending on what z is. And this is because this solution has infinite number of solutions. Okay, we'll pause here and look at objective 6 in the next video.